Hello and welcome to York Universe, the astronomy and astrophysics radio podcast now, written and presented by students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening, Dr. Elena Hyde, and I'm joined tonight by Sana Withers. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night, from radio to podcasts and beyond, at 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. UT, if that's more your speed. You can also find us working with the York U Observatory online public viewing program over on YouTube. That's right, it's on YouTube as well. So as of I believe October 2024, you'll also find us now wherever podcasts are distributed. So that's the way we say podcast radio show. If you are watching live on YouTube on the Monday night, you will of course get the full live show, complete with images, archival or live from the telescope, and chat over on YouTube with the OPV team. For all of the links for the live show, archival episodes, and more, check out our website, www.yorku.ca/science/observatory. If you are navigating around to go live from this podcast, you can go ahead and go to OPV Online Public Viewing or click on any YouTube link. For any questions, comments, or past shows, and of course, suggestions for future topics, you can always send us an email at observe@yorku.ca. And of course, you can connect with us on social media on Instagram, York Observatory, and Facebook at Allan Carswell Obs. All of our programs are free, but if you would like to make a donation to that same website, yorku.ca/science/observatory. Now, if it is indeed live for you tonight, you can go ahead and go over to the YouTube chat room for questions and post content. The current weather in Toronto is not particularly promising. So we are actually looking at archival images and not live from the 1 meter tonight. Boo, I know. So how is it where you are, Sana?
It's also not great here. It was a little weird the other night when we were trying to observe. It actually ended up being clear at York, but when I got home, it had been raining in Aurora, and I'm not that far off from York, so it was a little bit odd.
Yeah, there's some very rainy looking blips on the weather area, sort of hovering around the telescope. So we will not be able to open tonight.
Mhm.
Fingers crossed for tomorrow, of course. But yeah, we're entering the not so good part of fall, it looks like.
Yeah,
So
I'm actually pretty impressed at how good the weather's been the past couple months. We've had quite a few days
yeah,
with clear skies.
first the I would say most of October has actually been extremely excellent.
Yeah, yeah.
Just recently not.
Yeah, the forecast for the next like week and a half is looking very cloudy, rainy. So I think we've sort of run out our luck.
Yeah, we can now all we can do is cross our fingers and hope we just get out a few more good clear nights before it starts getting really properly cold up there.
Yeah.
Now, if it does clear up, there's all kinds of wonderful things we'll be able to see. And of course, we'll talk about announcements as well. We have been keeping a careful eye at T-Core Bohr over at the observatory. I know that you've done a lot of observing for it as well. But as of yet, it hasn't exploded, much to our disappointment. Although, checking the news, maybe any minute now.
Yeah.
But, of course, star explosions are one of the, I would say, probably one of the more appropriate things for this time of year, given that we have Halloween coming up on Thursday.
Yeah, lots of dead stars.
Exactly. Spectacular ghostly images out there.
Yeah, so I guess that sort of brings us to the first this week in space and astronomy history pretty well, which was November 2nd, 1572, when the Type 1A supernova went off, known as SN 1572 or Tycho's supernova. So
That was so long ago. That's just it's amazing that we have good records from that.
yeah, yeah, it's pretty remarkable. So one of the reasons why it's called Tycho supernova is just because astronomer Tycho Brahe studied SN 1572 a lot, and we're going to talk about him and Johannes Kepler a couple of times in this episode. But Tycho Brahe specifically was really well known for taking like really detailed observations of the night sky. And again, this is like such a long time ago in 1572. The telescope was not yet invented at this point. So he actually made a whole lot of his own instruments to observe the night sky and to observe stars. And he was able to take these like really crazy detailed observations of the night sky in 1572, which is very remarkable. I don't think I could actually observe the sky that well if I was in his position because it's just kind of crazy the stuff he was able to do. Um, but about SN 1572 specifically, nobody knew what this thing was when the supernova went off. And instead, all anybody saw was the appearance of what looked like a new star in the constellation of Cassiopeia. This new star was incredibly bright. At its peak, it was estimated to have a magnitude of about -4, which makes it about as bright, or maybe even a little bit brighter, as Venus. It was so bright that it could be seen during the day for, as I recall, several weeks, and was visible to the naked eye for about 2 years until 1574. So, this really weird new star that sort of freaked some people out. Some people saw it as sort of a bad omen or an evil omen at the time, but it was also very interesting to people like Tycho Brahe, who were interested in the night sky and understanding what was going on. So Tycho Brahe ended up studying the star a lot, both himself and by collaborating with other astronomers and comparing his observations to theirs. In 1573, he published a paper called "Concerning the Star, New and Never Before Seen in the Life or Memory of Anyone," and then updated this a couple of more times in the coming years based off of him comparing his observations with other people. Now, at the time, even though nobody actually knew what SN 1572 was, it did have some important implications for the understanding of astronomy and space at the time. Because this was 1572, their picture of what the universe looked like and the Earth's place in the universe was very different than it is today. And they just kind of saw the universe as being this sort of static thing that didn't really change. They knew that there were some things that existed in the universe that were very far away from us. From what I've been reading, it seems that their standard for that was that things that were further away from us than the moon. But apart from that, they thought that all of that stuff more or less stayed the same over time and did not change. But Tycho Brahe's observations of this supernova, and of course everyone else's observations of it, started to really show that that was not the case, and that new stars could appear and then later disappear in the night sky, which is a pretty important result back in 1572. Now, the supernova remnant itself is actually still visible in the optical, radio, and X-ray, and has been studied in a bunch of different wavelengths for, I think, even up to today, pretty much. In 1954, after various studies of supernova 1572, it was determined that this object was what's called a Type 1A supernova explosion. And this is what happens when a white dwarf star, which itself is the dead core of a star, of a sun-like star when it dies. When a white dwarf star orbits a main sequence star, it can start to pull mass off of the main sequence star and grow in mass as it does this. Eventually, it hits something called the Chandrasekhar limit, which I believe was talked a little bit about last week as well, which is a limit of about 1.44 solar masses and the maximum mass that a white dwarf star can be. It's supported by something called electron degeneracy pressure, and it just cannot get any bigger than that and still be supported by electron degeneracy pressure. So once the white dwarf star has siphoned enough mass off of the companion star and reaches the Chandrasekhar limit, it blows up in a Type 1A supernova explosion. So this was debated a little bit until around 2008 when some follow-up observations ended up confirming that it is in fact a type 1a supernova. So this is pretty cool, a pretty cool anniversary or item for this week in history. Like you said, just because it's so long ago in 1572, and it still remains one of the very few supernova explosions in the Milky Way galaxy that have been recorded by humans. So pretty cool.
Oh yeah, absolutely. And it's I mean, not just because it's been watched for so long, but because this supernova remnant, I mean, I actually remember studying this as a project in actually one of my master's classes back in the day, because you can still measure the change in velocity that occurs in even since modern times as the gas from that explosion continues to expand out into space. Because as far as the star is concerned and the supernova remnant, it's just happened. But for us, this was a long time ago, 1572, as you say. And I just love that it was measured so accurately and so memorably, because it really is, it just kind of emphasizes the very difference in time scales for the fastest things that stars can do, which is explode, and the incredibly tiny lifespans that all of us humans have in comparison even to that.
Yeah.
Um, so
Like T4 it's taking its time
yeah.
up. So
Yeah. Yeah, and I mean, once if T-Core board does actually explode, that will also be something that we can watch for a while. We don't expect it to be a Type 1A, but it will still be pretty interesting.
mhm.
Um, I can forget what exactly I'm mixing up my supernovas now, but I forget what because T-Core Bohr is a type, and I'll fill in the blank in the comments as a quiz. Um, we'll go find out. But yeah, it is particularly interesting. I thought the measurement style that that was used, as you say, it was before telescopes. And as far as I know, the Uraniborg Observatory from Tycho Brahe, one of the key instruments they did use, because they did not have telescopes, um, were things like quadrants. And these were very accurate, sort of mechanical arcs, basically, that you could hold up to the sky to measure things like arc minutes, arc seconds, and degrees, because the sky you could still divide up into degrees. And by making the instruments more accurate, you could use your eye to do these measurements. And things like sextants were also of the time, but the original quadrants were so much older than that. The quadrants were actually thought to have been invented for astronomical measurements in the Islamic world, and I believe there's records of them being used as far back as about 1000 BCE. So they have been around for a while by the time Tycho Brahe got to them, but he made them sort of bigger and better than anyone had ever seen before. So, without getting a telescope, this was kind of the JWST of the time, right?
Yeah.
So several buildings and very, very, very large but accurate ways to measure the sky, just
Yeah.
ground-based.
Yeah, like state of the art observatory of the time.
Yes, exactly. And it is interesting to note as well as, at some point technology kind of reaches as high as it could get in one area. And this is how all these astronomical measurements were being made for hundreds and hundreds of years. Quadrants and sextants and people holding up mechanical devices to the sky and looking across them, trying to see with their eye the best that they could see. And and then comes along a telescope. And it completely changes the entire industry. And
Mhm.
all of a sudden, you could see things like moons and other interesting stuff. Anyways, very, very, very fun.
Yeah.
And I had to look it up because T-Core Bohr, it was bothering me a little bit. The recurrent nova is currently what I'm seeing on here.
Okay. Yeah, I always forget the classification of that one too.
Yeah, yeah. Don't try to remember too many astronomical terms late at night. You will get them mixed up. Just don't call don't get mixed up between like Vega and Polaris. That's if you're doing navigation, that would be a very bad one.
Yeah, that seems like a disaster.
Yeah. But a very, very if you're going to have a disaster, I think the getting a disaster of a exploding star would be way, way better.
At least it's a
So
cool one. If it's far enough away, it's a pretty fun one to see. So
yes. Well, if you're too close, at some point you really don't have to worry about it.
yeah,
Um,
I guess you don't. Yeah.
but that's about 5 billion years away or so, as far as I can tell.
Not
Um,
something we need to
and
worry about today. Spooky.
no, no, and Proxima Centauri is so low mass, it's going to be even longer.
Mhm.
By the time we have to worry about that one, it'll be far, far away.
Yep.
Um, Anywho, speaking of things far, far away, I thought I would continue our ancient times and sort of spooky facts with another supernova, and also related to Uraniborg, but this time it wasn't Tycho Brahe. It is actually Kepler, who was, of course, famously came to work for Tycho Brahe because of his awesome observatory. And this one's a little bit complicated because it's later, but it was today, yesterday, and actually all this month of October. The supernova 1604 was observable. So supernova 1604, so it happened in 1604, but it was observable for almost a year, from October 1604 all the way through to October 1605. This was a quite a beast. So this is also called Kepler's supernova. So Kepler and Tycho, they were just really in the right place at the right time because boy, they got Tycho's nova in 1572, and then just a few years later, well, 30 years later, they had supernova 1604. And this one officially went off, I think, on the 8th to 9th of October, but by the 28th of October, it was actually being observed. So 8th to 9th of October 1604 is when we think that Kepler's supernova actually exploded. It appeared in the constellation Ophiuchus, and it was a type 1a supernova. So as we've heard before, this is one where you have the binary system in which one star is a white dwarf and the other star can be anything, um, anything big. And in this case, we think it was a large star. So this was the second supernova to be seen in a generation after Tycho Brahe. And since this one, no other supernova have been observed with certainty in the Milky Way. Although we did have some nearby, of course, a supernova 1987A is very famous, but we did have one in Andromeda in 1885, and a few others around there. So supernova are not really common, which is probably good because they're very energetic. And you wouldn't want too many of them in your neighborhood. But yeah, so this one was observed for a long time. And it actually makes a prominent appearance in a very, very famous book. I have a penchant for old books describing astronomy events, and this was De Stella Nova, written by Kepler. And the book was published in Prague in 1605 and 1606, so right after this occurred. And of course, he named the supernova in there. And it is pretty fun. So it's about 20,000 light years from Earth, nice and far away, no danger at all. And it did get fairly bright. So when it exploded, it was brighter than any other star in the night sky. It got to an apparent magnitude of negative 2.5. So at that point, it was outshining most of the planets. And it was recorded not just by Uraniborg, not just by Tycho Brahe and Kepler, but also in Chinese, Korean, and Arabic observatories. So very, very exciting, and basically the last real blast of excitement we've had from supernova in quite a while. Now, we do know that Kepler's supernova is a little bit of an oddity. There's a lot of discussion about exactly, how prototypical it is. Is it the normal? Is it the normal prototype of its kind? And it's been studied extensively, as has, of course, Tycho's supernova remnant. So those you can still see today. So if you have a good enough telescope, you can go out and look at Kepler's supernova remnant and Tycho's supernova remnant. Currently, it is not very bright, so its visibility now is gosh, I think it's around 18. Was it? I'd have to check that, but it is you'll need something like a 1 meter telescope to look for it, and you know, being called both Kepler's supernova and, of course, named after the year. So the 1604 is the current sort of modern way of naming supernova. You just put SN and the year they blasted off, basically. And the interesting thing about it as well is that not only were they looking for things in the sky, they were actually very interested in conjunctions of Mars and Jupiter, because at the time in Europe, they had begun to more accurately predict the positions of planets. Obviously, Kepler was about to help a lot with that, with Kepler's laws, and giving the planets elliptical orbits around the sun, which will increase their predictions of planetary positions. So there was actually going to be a conjunction of Mars and Jupiter, which was going to be linked to sort of, at the time, it was thought to be kind of a link to the Star of Bethlehem. But of course, they got clouded out, and the supernova was happened. So the supernova happening around this time kind of was a big deal. Kepler wasn't able to start observing it until I think about 12, was it? So it came off on 8th to 9th of October, and he was able to start on the 17th. So he missed the first couple days of peak brightness, I suppose, while working at the Imperial Court in Prague. So a very, very glamorous position. And even though he was not the first person to see it, he tracked the observations for an entire year. And the nova got named after him. So Kepler made very, very good detailed records of the supernova, and because his were the best, and I guess he had the best patrons, he actually got ahead and got it named after him until they changed the naming convention, as can happen occasionally. So obviously there were a lot of thoughts at the time about the supernova that had come off. They did not know what it was, but as mentioned by Sana, it shows that it's an imperfect, all of a sudden, an imperfect cosmos. Something changed in the background stars, which people were not expecting, and then it disappears, which was very, very unexpected. So it's a mystery at the time, and a little bit of a mystery still. So the supernova remnant from this explosion was always thought to be out there, but we couldn't actually see it until we had telescopes good enough in 1941. So from 1604 and 1605 to 1941, the actual remnant remained a mystery. out there in space, expanding into the darkness. We had to get telescopes good enough to be able to see it, which is just, I think, another very cool sort of, I guess, semi-Halloween crossover. And the available evidence, looking at what we can see now in the gas, we think type 1a supernova um, was what happened. So a small white dwarf accreted enough matter from a companion that it exploded completely. And the X-ray spectra is actually one of the most common images of the Tycho, or sorry, the Kepler. I didn't get them confused. Of the Kepler supernova remnant, the Tycho's supernova remnant actually looks really similar. So if they're both truly Type 1a supernova, then the differences and similarities between them are really interesting. So a lot of people today are studying them and trying to see what is the expected outcome for these type of supernova. How much can they vary? And given that this is only 2 data points, a lot of debate can be had. So the progenitor star is, I think, still argued about, but a large star is likely, and it is pretty fun because you can get so many different reactions with a 2-star system. There's a lot of possibilities. So the images show the nebula is a little bit messier than some other supernova that we've seen. Maybe like, for example, in the Large and Small Magellanic Clouds, there could be some sort of runaway star system happening. Like, for example, sometimes stars get high velocity and they move with unusual velocity through the galaxy, and that can completely mess up how the models fit your data. If you're going at an unusual or unexpected velocity, shall I say. And the current thought, all at the end, what we think has happened is that a large star that had likely already passed through the asymptotic giant branch and expanded gave too much of its mass to a white dwarf companion, and the resulting explosion pretty much destroyed everything. So very, very sort of spooky remnants out there in space. I'm not sure if it looks totally like an eyeball, but I will say that the X-ray images of 1604 do look just a little bit like a zombie eyeball. So that's my Halloween crossover. And of course, with the any kind of spooky object, you always kind of get a little bit of your human's brain impression on, taking over what you think the image really looks like.
Like the cheeseburger nebula.
Exactly like the cheeseburger nebula, which I remember taking pictures of and being like, yes, this is definitely a cheeseburger. So, and no surprise at all, of course, that the ancient names are what people used to think about, and now we have sort of, I suppose, more modern cheeseburger thoughts when it comes to looking at these. The supernova remnants, they definitely look more haunted, though. They look like they could be in a haunted house for sure.
Oh yeah, yeah. I think my favorite has got to be the Crab Nebula, especially in X-ray, because you can see like almost like a disk of gas just swirling around the supernova remnant there, which is pretty awesome and pretty spooky in X-ray.
Oh yeah, it looks very haunted. Highly recommended. And of course, supernovas aren't the only creepy haunted things out there.
No, lots of fun haunted things out in space.
And I think actually that might get us to your next object.
Yes. So it really truly was a great time to be an astronomer in the 1500s and 1600s, because in 1577, on October 27th, the what's called the Great Comet of 1577 passed through perihelion. Now, there has been, of course, a lot of excitement about comets recently because of Comet Atlas, and there was also that potential Halloween comet that we might have gotten this month, but I don't think so. But back in October 1577, there was also a lot of excitement over a different comet. Now, this comet's specifically is called a great comet because it just passed very, very close to the sun. And the closer a comet passes to the sun, the more material will evaporate off of the core of the comet or the nucleus. So, just because this comet passed so close to the sun, there was a ridiculous amount of stuff like carbon dioxide and water vapor and other dirt that is in the nucleus of a comet that evaporated off of it and left this really fantastic, bright, and massive tail to the comet behind. Now, the Great Comet of 1577 ended up coming within a distance of 0.178 AU from the Sun at perihelion on October 27th, 1577. But not only that, it was also very close to the Earth. It had its closest approach to the Earth on November 10th, 1577, coming within about 0.63 AU, which for a comet is actually very close to us. Now, because of the combination of the comet being so close to the Earth and also so close to the sun and so huge and bright, it was kind of a monster in our sky. It was estimated that it was as bright as about -3 or -4 magnitudes. So, according to some reports, it could be seen through some clouds. It was just that crazy bright. Now, of course, one of the astronomers who observed the Great Comet of 1577 was Tycho Brahe. Of course, he would be observing that just because of how big and fantastic this comet was. He ended up taking a whole bunch of very detailed observations of the comet, as he does with anything that shows up in the night sky, it seems. And one of the things he concluded from his observations was he was able to measure an approximate distance to the comet. It wasn't super detailed, but he was able to compare his observations with observations that other people in other areas of the Earth took of this comet. He was also able from that to calculate essentially a parallax, so how the apparent position of the comet changes depending on where you are on the Earth. And just because he could not find any notable parallax for this object, concluded that it has to be very, very far away, several times further away than the moon. And again, this was sort of setting the scene that the heavens above and things in the cosmos could change over time, which was itself a big result for the 1500s, 1600s, and also ruled out the suspicion that a lot of people had that comets were actually due to some disturbance in the Earth's atmosphere, making sort of something that looked really bright and fabulous in the sky, but was actually within the atmosphere. So yeah, this was definitely a fantastic period of time to be an astronomer. I'm a little bit jealous. I really want to see some sort of supernova explosion, and a great comet would also be really cool. But unfortunately for us, the Great Comet of 1577 is not going to come back to the Earth and put on another great show. According to Tycho Brahe's calculations and his measurements, it's estimated now that the Great Comet of 1577 is about 320 astronomical units away from the Sun. And for reference, Neptune is only about 30 astronomical units away from the Sun. So it's very, very far out there. It is really not coming back. So hope we'll have to sort of cross our fingers for a different great comet to show up in our lifetime.
Yeah, and that is one of the things with comets. I mean, we've seen two just this month. They're so unpredictable. And you can have a comet come in that looks like it's going to be nothing and do amazing things, and you can have comets come in that look like they might get giant and then they just fall apart because they got too close to the sun. So it is I think the in unpredictable nature of comets that has again, really captured a lot of people's imagination. And it is worth noting that comets do have pretty significant I suppose reputations, and there's a lot of mythology around them as well. So that Halloween comet would have been a pretty big deal, especially I suppose in over Europe.
Mhm. Yeah,
What
sorry, yeah, there were some people who actually interpreted the comet as sort of a bad omen or a bad sign of things to come. Because I mean, what would you think if this massive bright thing just showed up in the sky and you didn't know what it was? Definitely a bit jarring.
Yeah, well, they had no scientific explanation for it at the time. And so, of course, there were conflicting religious explanations that people came up with.
Mhm.
But, comets have, for better or worse, maintained, I think, a very spooky reputation. And it's not for nothing that even in the modern day we do have science fiction films like is it Deep Impact and the other one, which were cometary things and asteroids headed towards Earth.
Mhm. Yeah, and I did hear
So
I did hear about also this like the Devil's Comet a while ago that kind of looked like it had the
horns,
two horns.
yeah,
Yeah.
yeah, yeah.
So
Yeah, and it is one of those things is it still captures the imagination, and of course scientifically we do know that it would actually be pretty bad if one hit the earth. So
mhm.
it's like, oh, maybe they do bear watching.
Yeah, they need
um,
to just stay like a little bit far away from us, but close enough they put on a nice light show.
yeah, I think 320 AU away is maybe too far.
Oh yeah.
But yes, and it is interesting that you mentioned, of course, Tycho Brahe trying parallax, because parallax as a method of measuring distance was known. And it was actually one of the very big arguments that people could not get past for, uh, you know, for real distances in that the skies could be changing, because the argument, at least in Europe, there was a very strong resistance to the idea that those little lights in the sky might be the same as our sun. That wasn't even a possibility, because surely, if they were distant, if they were far away, we would be able to measure a parallax. And being too far away to measure a parallax for, even for a comet, this was actually a really good clue that maybe more things are too far away to measure the parallax to, and they're not actually completely separate objects. It wasn't until uh, substantially later. Um, so this was, we're talking hundreds of years later. The first successful parallax was not until the 1800s. It took that long to confirm how far away the stars really are, because it's really far away.
Mhm.
It's so far that you have to have basically modern instrumentation to measure it.
Yeah.
So it wasn't until the 1800s that they finally found out how far away things really were, or at least some things.
Hmm. Yeah, it's still like remarkable how much is considered sort of common knowledge today that it's interesting hearing about how some of these things were discovered. You know, like the thing that always gets me is that humans did not really know that other galaxies existed until about more or less 100 years ago, I think, that it became more widely accepted. So it's kind of crazy to think about the way a lot of these things were discovered.
Oh yeah, and I mean, being able to measure it is all very, very new phenomenon. I
Hmm.
mean, we have tens of thousands of years of not knowing what's up there.
Hmm.
Only very recently, I mean, it's the 1800s, do we actually have distances? And that's one of the great things to think about as well, is, if you really want to get that spooky feeling this week, go ahead and try to picture some of the distances involved. Just
Yeah.
start at Earth and see if you can get out to the Sun and Jupiter, and from there, um, just go to Proxima Centauri. And if you can get that distance pictured, the sheer vastness of space is, I mean, it's not at all surprising that it took us this long to figure out.
Oh yeah. Oh yeah.
In any case, speaking of olden times, I suppose we do have one more to get to for This Week in Space and Astronomy History, because of course Thursday is Halloween. I'm going to go back in Halloween times, but we're going to go back so far that I probably can't reliably use the Gregorian calendar anymore. But we're going to go October 31st, but all the way back to the 11th and 12th centuries. So October 31st is Halloween, as we know today, at least, for several countries around the world and lots of parts of the Northern Hemisphere. And Halloween being on October 31st is actually not an accident. Um, in olden times, pre sort of Halloween as a holiday, in Europe, and in particular in the British Isles and Ireland, and they had a holiday called Samhain or similar, which was marking a astronomical event in the 11th and 12th centuries in particular. Samhain was very, very prominent, and this was a mark of an interesting conjunction with the Pleiades star cluster. Very spooky, beautiful, glowing blue stars, even with the naked eye. Sometimes called the Seven Sisters, even though you can only see six of them today. It reached its highest zenith at midnight on a cross quarter day, um, on basically October 31st. So, what happened? The cross quarter day for 2024 is not until November. So that's when the Pleiades will be at the highest point for our position in the northern hemisphere. So it's still marking the Pleiades is still marking the cross quarter day, but the cross quarter day is now in November and not in October. So this is actually one of my favorite Halloween fun facts, and it has to go with a little bit of history, a little bit of I suppose politics. But about 1000 AD, or about 1,000 years ago, the Catholic Church in the Northern Hemisphere made November 2nd All Souls Day to replace the Celtic festival Samhain, because they wanted their own festival to kind of overwrite what had been before. This would be a related church sanctioned holiday, where people could still do similar things, but it would then be church related rather than that other religion that happened to already be there. So the All Saints Day celebration was also called All Hallows or All Hallows Mass. And what they would do traditionally is they would not carve pumpkins, they would carve turnips. And if you want something completely and utterly terrifying, look up a original carved turnip. They are way scarier. That's probably why we use pumpkins. Less scary. But I keep mentioning cross quarter days. Cross quarter days are the days that mark the middle point between the equinoxes and the solstice. And if you think about how your calendar is arranged, if you are most interested in planting and harvesting, you really need to know what time of year it is, what time of year marks harvest time, what time of year marks your planting time, and all that good stuff. So we have solstices, which are the longest and shortest day of the year. We have equinoxes, which are, of course, the middle point. That's the sort of most even between your day and night for whatever place on Earth you are. But the cross quarter days, those are the days that exist exactly in the middle. So if you're counting your way around the seasons, if you're using an ancient calendar, you're not going, January, February, March. You're going so winter solstice, cross quarter day, equinox, summer solstice, cross quarter day, equinox, cross quarter day, winter solstice. So that would be 1 year. And the cross quarter days are really, really much better ways to mark the seasons. It has been noted before, but when you hit that cross quarter day, that's when you really feel it. So if we had the equinox quite a bit ago. The cross quarter day coming up soon. Once we hit that cross quarter day, I think it's about November 7th, but you guys can check me on that in the comments. Um, once we hit that, you're really going to say, okay, now we've really hit the beginning of the real change to the season. So marking the cross quarter days between the solstices and equinoxes means that you have a really different way of setting up your calendar. So Halloween, one of the spookiest cross quarter days, this actually had a festival associated with it for the autumn and to mark the coming of the longer nights and shorter days. And if there are cross quarter days, two equinoxes and two solstices every year, you can probably guess how many cross quarter days there must be, right? So there must be 4 of them marking around your sort of calendar. And October 31st being fixed as a day for Halloween, that's a little bit of a calendar sort of accident because October 31st was the cross quarter day. But our calendar no longer obeys the alignment of the stars. So we are constantly adjusting our calendar with leap minutes and leap days, but the cross quarter day is still drifting. So the true cross quarter day, I think, was again November 7th or 9th or something like that. And according to ancient Celts, that's when you really have the beginning of the season. So you can, you can realign your calendars appropriately, I suppose. But it is this week is when we have Halloween, even though we're not necessarily aligned up with the Pleiades anymore. The Pleiades are getting pretty good, and of course, at their highest point, they'll be very, very easy to view in the sky. The Pleiades are, close to the ecliptic as well. So if you're out there doing stargazing, of course, you have the constellations of the zodiac, the constellation of Taurus, the constellation of Scorpio, all along the ecliptic, and the Pleiades are right up there as well. So they would have been very significant stars, and you would have frequent occultations and clusters with the moon and the planets. So lots of opportunities to align yourself and to watch, use the Pleiades as a little bit of a alarm clock. So the near dawn or heliacal rising of the Pleiades in spring from the northern hemisphere was basically the opening of the seafaring and farming season, and the dawn autumnal setting was the season's end. The highest point, of course, marks the season that we're about to start right now. So if we go back to the Bronze Age Celts, we can ask ourselves how the stars would have appeared, 10,000 years ago, 20,000 years ago, 26,000 years ago. We have things like precession of the equinoxes. And it is worth noting that over long enough time periods, not just the Pleiades are going to shift, but over 50,000 years, our ancient ancestors would have actually observed things like different constellations, different pole stars, completely different set of alignments for things on the equinox. So it is, I suppose, a little bit of a fun and haunted time of year, but I like to think of it as probably the most astronomical of all the holidays.
Yeah, I did Google the carved turnips, and I think that's the most haunted thing. I was not expecting that.
Yeah, yeah. It is. I think they use pumpkins now because turnips are too scary.
Yeah, that was a little creepy.
It really is. It's legitimately scary. So maybe don't show it to too young of children. But in any case, now that we've completely scared everyone, I think it's probably a good idea to do some reminders that because this week is Halloween, we will be doing a special Halloween tour at the observatory.
Yeah, so I'm very much looking forward to the haunted Halloween tour on Thursday this week. So no tour on Wednesday, but on Thursday this time. We'll be decorating the observatory with a bunch of Halloween decorations and making it spooky. And I guess fingers crossed for some clear weather, so we can actually observe
Yes.
some spooky things in the night sky as well.
Yeah, of course, it being cloudy makes it like a little bit too scary. But even if it is cloudy, we'll still have the observatory all decorated. So if anyone is planning to come out for the free tour this week, just make sure you note the ticket is for Thursday and not Wednesday because Halloween is on Thursday and we can't do a Wednesday tour and a Halloween tour back to back.
Yeah.
So we're going to do just Thursday this week, and it's going to be awesome. There will be candy for any kids trick or treating. You will only be able to get it on your way out of the observatory because the telescopes are actually very much allergic to food. But it'll be fun. There will be decorations and, of course, lots of fun astronomy facts.
Yeah. So is the
Um,
leader gonna dress up as anything for Halloween? Or
we do have a large black cloth, but other than that, I think probably we're not going to dress it up too much because it would involve getting up on the ladder.
yeah,
Um,
we could throw a white sheet over it and say it's a ghost, but
yeah, if I'm able to find those extra big googly eyes, then maybe we'll see.
that would be cute. That would be cute.
Um, but that said, we do have one other actually really scary event coming up. That's not on Halloween. Daylight savings time.
Yeah, I'm actually happy about daylight savings time ending because we get earlier sunsets. So that's happening this coming Sunday on November 3rd. We have to put clocks back um ahead or I think ahead.
Fall back, I believe is
Fall back.
the
Okay, yeah. So
yeah,
back
yeah,
turn clocks back 1 hour on Sunday.
exactly. And so, unfortunately, this is going to throw off all of our astronomical calculations. I think we should just go to winter time and stay there, but we all have to do it. So just watch out. It is after Halloween, so it's a little bit of like the trick after the treat, I
Yeah.
suppose. Because it is absolutely designed to make you go to places at the wrong time.
Mhm.
But watch out, everyone. It is on its way.
Yeah, but earlier sunsets for observers. So
Yes, yes. At least once we adjust, we'll be in the what I would like to refer to as the correct time zone.
yeah, yeah, I don't
Ideally,
like
I
the
mean,
whole time.
it would be better all year because I would much rather have an earlier sunset in the summer. That would be
Yeah.
so much better.
Oh my
We could
God.
start.
Yeah.
Would that be?
Because
Because we'll start an astronomical petition to keep the sunsets earlier in the summertime.
yeah, it's so annoying not being able to do like any observing until like 9:30, 10 o'clock in the summer.
Yeah, it's
And it's kind of taking me by surprise now because sunset is getting earlier. So it's like 9:30 and we're talking about packing up and leaving soon because we're done observing and I'm a big fan of the early sunsets. I can actually get home
oh
after.
yeah,
So
yeah. It's great. I mean, by the time we go through this and get into proper time, we'll be able to start up everything at 5 and set a program running so the telescope runs itself all night.
mhm. Yeah, and then we can sleep.
Yeah, I mean, provided there's somebody checking it once in a while, but yes.
I'll wake up every couple hours and check in on the telescope if it means I can get a full night's sleep. But
Oh yeah, absolutely. And that's why we have cameras now. So don't anybody try to break into the observatory. We do have cameras.
and we can also hear you on the cameras too.
That's true.
So
Although, do we really want to be warning everyone that the ghost sounds are coming from us?
that's a good idea. Maybe if they think the observatory is haunted, that might be safer.
Yeah. All right. So haunted observatory on the way. We should probably try to do some news items though. Where
Oh,
you've
yeah.
got JWST finding spooky explosions not too far away.
Yes. So JWST is now able to start expanding the number of supernova we can observe, or supernova remnants specifically, that we can observe in the relatively nearby universe. Before JWST, we were only really able to observe supernovae within the Milky Way galaxy and within some of the very close dwarf galaxies that orbit the Milky Way, like the small and large Magellanic Clouds. But because JWST is so sensitive and it can take really, really high resolution pictures, we're now able to start studying supernovae in other nearby galaxies, like the galaxy Messier 33, also known as the Triangulum Galaxy. So there was a paper that came out from JWST that for the first time got what's called spatially resolved observations of supernova remnants in Messier 33. So basically that just means it's able to look at a like high resolution detailed view of what's going on in the supernova remnant, as opposed to just seeing the supernova remnant as like a couple of pixels on the detector, which is what you see for supernova remnants that are very, very far away. So this is pretty important because we're now able to start studying many more supernova remnants and also different kinds of supernova remnants and see how they change depending on if they're within our own galaxy or within other galaxies. So this one in particular was just sort of a first look at what JWST can do studying relatively nearby supernova remnants. It observed 43 of these things in Messier 33 and found a couple of important results regarding how shock waves from the supernova explosions can propagate through the supernova remnant itself, how they can influence the gas and the dust nearby and potentially trigger events of star formation, and also learned more about how dust, for example, is created in these supernova explosions, which can also influence how galaxies can evolve and change over time. So pretty interesting result, another pretty interesting result out of JWST, and definitely a bit of a spooky one too, because it is observing dead stars.
Oh, absolutely. And of course, as we said before, supernova remnants, they just can't help but be spooky. And of course, trust JWST to be able to bring us supernova remnants outside of our galaxy quite easily.
Mhm.
And it is actually the perfect, I think, article because we were just talking about, if we were to go back in time to the 1500s, I think Tycho Brahe's Uraniborg basically would be JWST,
Yeah. Yeah.
which makes me think that maybe with our JWST, we will get some Tycho Brahe type results.
Oh
So,
yeah, yeah. JWST has been observing tons of supernova. Even just apart from this specific paper, it's been observing like supernova in the distant universe for the first time. I think I
oh yeah.
accidentally found a supernova in some of my JWST data actually, which is pretty
Oh,
fun. But
wonderful. Now see that is a happy accident.
yeah,
And I mean, in other galaxies, they can explode as much as they want. We don't have to worry.
yeah, yeah. 33 is
So
probably like,
wonderful.
yeah. Oh, sorry. Go ahead.
Oh yeah. No.
Yeah, I was just gonna say M33 is probably like the perfect distance for that because you can observe a good number of them, but they're still far enough that we don't need to worry. So,
Oh yeah. I mean, it actually has to be fairly close inside our own galaxy before we need to be much concerned about it.
mhm.
I mean, obviously, if it's a active galactic nuclei, we do need to be a little more concerned. Um, but that's not likely to happen in the Milky Way either. All right, so there's one more tiny little news item that is a little bit spooky. We talked about basically supernovas and comets today, and comets, oh my gosh. So much like the 1500s, we have comets, but we did not get a great comet. We got a pretty okay comet, which was, of course, we have had two. So we had, of course, Comet C 2023, which is not to be confused with Comet C 2024. So Comet C 2023 at Tishushan Atlas, this was the one that made spectacular photos in the southern hemisphere. Beautiful, beautiful pictures coming out of the south, and then put on a reasonable show in the north before moving out of our view. It is still up there, but it's very, very, very faint at the moment. So C 2023, and again, we really need to work on our naming things for this. I'll just call it 2023A3 because the other comet, the one that's just happened, is C 2024 S1. And after we had this 2023 comet come by, Comet A3, we were able to see it. A couple bunch of people got pictures, even from the observatory crew. I know some people got some really good pictures. We got a little tiny mini live stream of the comet core for this one. It was actually visible, very, very fun. Not as good as that green comet we had the other a while ago, but pretty good. But the next one coming up was thought to be, oh, they're getting very excited, Halloween comet possibility, and it ran up and it got a little too close to the sun. It looks like so. Um, Basically, Comet C2024 S1. This is a newer one. This has met its demise. It is almost certainly gone. It has evaporated as it was going towards the closest point to the sun, and basically it was getting closer and closer to the sun. And we're like, oh wow, it's gonna get so much stuff evaporated off. It might really get big, but it got too much stuff evaporated off, and thanks to the wonderful spacecraft that are in orbit, we actually know exactly when Comet uh, 2024 S1 met its demise. So its final moments were on October 28th, 2024, which is today, and it flew towards the sun and got too close and did not come back. The comets are very, very unpredictable. Even when we know their orbits very well, we cannot predict if they'll make it past the sun and what they'll do after that. They can break up, they can go into fragments, they can not make it past, they can come past with a spectacular show, or they can come past with basically no show at all. So, very few of them are predictable, but that makes things like Halley's Comet all the more exciting, I suppose. All right, so spooky dead comets and spooky dead supernova. I think it's about time to thank everyone for joining tonight. Thank you all for coming by, and you have been listening to York Universe, the astronomy and astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Sana Withers and myself, Dr. Elena Hyde. And for any other content updates and contact info, you can find everything on our website, yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies, and have a good night.
Have a good night.